Hello everyone and welcome to live lab number 15 on how to build, train and tune a state-of-the-art machine learning model on this time EC2. Because indeed in the previous live labs, well, you learned how to build, train and tune a machine learning model on Lambda, right? That was live lab recording number 7. Remember, live lab recording number 7, deploy machine learning pipeline on AWS Lambda. So you know how to run a code in AWS Lambda. You know how to build, train and tune a machine learning model on AWS Lambda. Also, you learned how to build, train and tune a machine learning model on SageMaker. We did not do that in a lab, but we did it in the Data Science in the Cloud course. But what you don't know yet, or maybe you know from your personal experience, but what you don't know yet is how to build, train, and tune a machine learning model on EC2, right? The simple compute service. And now, well, you're about to learn how to do it for EC2, okay? That's the only thing missing, really. The three main services of AWS where you can build, train, and tune a machine learning model are EC2, Lambda, and SageMaker, okay? So now you're gonna learn about EC2. So going back to here, I'm gonna share my screen now and we'll get started. The entire screen, share. Okay, can you all see my screen? Is the sound okay? Just want to make sure before we get started. Please share in the chat if all is good, if you can see my screen and if the sound is good. Yes, Ray? Okay, good. Perfect. Okay. So good. All good, Jerome? Perfect. So now let's get started. Let's all go to the console home to access, of course, EC2. But first, I'm going to present to you, introduce you to the data set, explain to you what it is about, show you a bit also the code, and then we'll start, launching that instance in EC2 so that we can run the Python code from it. All right, so make sure you all downloaded the data set. You will find it in the event of today, of course, live lab number 15. I attached the data set at the end, live lab number 15.zip. It's a zip folder containing not only the data set, but also the code. So make sure to download the zip folder. You can also find it, by the way, in live lab recording number 15, which I already created. You can also find it here, code and data set attached, live lab number 15. So make sure to download it. And now I'm going to explain to you the data set and the code. So the data set is an insurance data set. So basically, it's a data set from an insurance company containing data about its customers. And in the data set, each row is a customer. This is a customer, this is another customer, this is another customer. So each row is a customer. And then for each customer, we have the age, the sex, gender, the BMI, body mass index, the number of children they have, whether they are a smoker, yes or no, the region they live in, so it's actually only southwest, southeast, or northwest. It's probably in the US. And then, of course, the insurance charges, which is what we want to predict, okay? So we want not only to build and train a state-of-the-art machine learning model that understands and learns the correlations between all these features going from age to region and the insurance charges, so that the insurance company can predict, more or less the cost of the insurance for each of the customers. And not only we're going to build and train a machine learning to do that, but of course, we're going to tune it, okay? And speaking about tuning, this is exactly what I'm going to show you now. I'm going to open the other file, which is regressor.py, which is the implementation of a state-of-the-art machine learning model, which we're going to tune on EC2. So we're going to go through the code sections one by one, just so that you can understand what they do. Here, this is the first code section. This is where we import the data set, that insurance data set, which I've just shown to you, okay? Here, this is a line of code that allows you to quickly check if there is some missing data. Actually, I can already tell you that there is no missing data in this data set. Here, because as you saw, I'm going to show you the data set again. As you saw in the data set, there are some categorical variable, okay? There are some categorical variable, like this one, female, the sex, saying female or male. That's a binary categorical variable. You also have this one, region, okay, containing 4 categories, southwest, southeast, northwest, and northeast, okay? So that's a categorical variable, which needs to be encoded, which is why we have that in the code. And also you have the smoker, yes or no, which is another binary categorical variable. So here, what we do in this code section is that we encode, we do label encoding. We binary encode the sex column just to turn female into 0 and male into 1. It doesn't matter whether female is 0 or 1. What matters is that we have 0 for one of the category and 1 for the other category. Then here in the next code section, we encode the smoker column, same, so that instead of having yes and no, we have 0 and 1. So actually it's 0 if the person, the customer, is not a smoker, and 1 if he or she is a smoker. Okay, and then same, we encode the region column, so that instead of having the names of the regions, northwest, northeast, southwest, and southeast, we have, so this time it's not 0, 1, 2, 3, so that there is no relational order between the region values, but instead we do what we call one-hot encoding, or dummy encoding, meaning we're going to create 3 different columns that encode each of the column values. So for example, the northwest region would be 1, 0, 0. Then the northeast region would be 0, 1, 0. Then the southwest region would be 0, 0, and 1. And the southeast region would be 0, 0, and 0. You only need 3 columns to encode the 4 values of the region. Okay? So that's what we do here. Then very simply, we get separately the input and the output. Okay, so here in this line of code, we get the matrix of features, containing all the columns from, well, let me show you again, all the columns from the age to the region. And then here, that's where we get the dependent variable, meaning the insurance charges, which is what we want to predict. Okay, so we get these 2 separately. Then we create the training set and the test set thanks to train test split from scikit-learn. Okay, so that we can have a training set to train our model on and a test set to evaluate the model. Then here in part 2 of the code, we first build the model, which is a random forest regressor model. So that's indeed not a state-of-the-art model, but one of the most powerful models for regression, because it will understand even the non-linear correlations that are in your data set, which probably is the case for this insurance data set. So a random forest regressor is not only powerful, close to state-of-the-art, well, actually, we're going to make it state-of-the-art in the sense that we're going to tune it to find the best combination of hyperparameters. So then here, that's where we build that model first without any values. Then here, that's where we train the random forest regression model on the training set, thanks to X-train, the matrix of features of the training set, and Y-train, the dependent variable vector of the training set. Then here we do just a little bit of inference to predict the insurance charges on the test set. And then here in part 3, that's where we evaluate the model. Okay, so we evaluate the model with R² and also adjusted R², which are the 2 relevant performance metrics for regression. Then here, in order to make the evaluation more relevant, we do some k-fold cross-validation to actually have 10 pairs of training and test folds so that we can have 10 different measures of the R², because the scoring metric here is R². And then we take an average of them. We take the average of them, and that gives us a relevant measure of R², because we compute that on 10 different pairs of train and test folds. Therefore, we make sure we're not lucky on a specific pair of training and test set. Okay, we also compute the standard deviation here just to make sure we don't have a too high variance. And then most important part, because we want to tune, this model, we want to make it as powerful as possible, as close to, the performance we would get from a state-of-the-art model. And so for this, we use grid search. And in grid search, which consists of testing many combinations of hyperparameters, well, as you can see here, indeed, we test all these values of the hyperparameters. So bootstrap, yes, we choose to have bootstrap, but we won't test whether we have it or not. We make sure we have it, it's better. Then maximum depth of the trees, the depth is the number of branches in the trees, the number of levels in the trees, you see? First branch, then second branch, and then at the tip, the leaves, okay? Then max features, okay? So that's the features in each of the nodes in the random forest, each of the trees of the random forest. Then minimum samples leaf, okay? So we're going to choose to have a minimum number of samples in each leaf. So either 3, 4, or 5. Minimum sample split, minimum number of samples in each split of the random forest, and then the number of estimators, which are the number of trees. So we're going to test a random forest with 100 trees, a random forest with 200 trees, a random forest with 300 trees, and a random forest with 1,000 trees. But what you must realize here is that actually we're going to test all the different combinations of these hyperparameters. Therefore, what is the total number of combinations we're going to test? It's actually 1, because we have one value here, times 4, because we have 4 values of hyperparameters for the max depth, times 2, because we have 2 values that we're going to test for the maximum number of features, times 3, because we have 3 values here, times 3 again, all right, and times 4, because we have 4 different values of the number of trees we want to test in our random forest regressor. Therefore, you can do the calculation. Let's actually check that. Let's take a calculator, all right, and let's just test the total number of combinations we're going to test, just so that we realize, just to get some motivation for using a server that is powerful enough to compute, all these performance metrics, all these scoring metrics for all these different combinations. So actually, yes, we said 1 times, okay, 4 times 2 times 3 times 3 times 4. All right, so we're going to test 288 combinations of hyperparameter values in order to find the best one, meaning the combination of hyperparameters that leads to the highest R squared, okay? Because that's our performance metric for regression. Besides, however, if you notice in the grid search that we're going to do here, well, we use CV equals 3, meaning we're going to have 3 pairs of training and test folds. I didn't choose 10 here, otherwise it would be too long, but we're going to have 3 pairs of training and test folds in which we're going to test, evaluate the model for all of these combinations. So actually, the number of computations for the R squared, in all these combinations and in all these 3 pairs of training and test folds is actually 288 times 3, all right, which is 864. So actually, yes, in order to tune this model, in order to find the best combination of hyperparameters according to a relevant measure of the scoring metric, which is the R squared, well, the code is going to run 864 computations of the R squared, meaning that it's also going to train 864 times the model, because in each pair of those training and test fold, well, it's going to train the model again in order to measure that R squared metric, okay? So that's why we're going to need a powerful server, and that's why we're going to get the result much faster than on our machine, unless you have a very powerful machine that can run this very fast. But that's the motivation here. We don't have to run this on our machine. We can just get a server super easily on EC2 and then do all these trainings, these 864 trainings, to get 864 measures of the R squared and then get the best one. Find the combination of hyperparameters that lead to the best one. Okay, that's the case study. Let me know if you have any question before we start. Okay, Federico, it's all clear for you? Awesome. Great. Thank you. So yeah, it's important that you understand the case study and the motivation, why we do this, why we need EC2. It's basically because we'll have a lot of training computations to make, and therefore it's much better to get a server that will do them fast for us. Okay, so there we go. Now let's all go to the console home. Let's go to EC2, and in the search bar you can enter EC2, and we're going to launch that new instance. And as usual, this is going to be an interactive lab where sometimes I'll give you some options of whether you want to do this or that. So actually, there's going to be the first interaction in a second, because we'll have a choice to make between whether we want to use an existing AMI with all the packages installed, to run the code, or if we want to start from scratch from, a simple EC2 instance, Okay, so let's do this. Let's click here, Launch Instance. And let's create our EC2 instance. So for the name, we're going to call it, let's say, how can we call it? We can call it my EC2 instance for machine learning. Okay, like that. My EC2 instance for machine learning. You can use the same name. It doesn't have to be globally unique. Okay, and now interaction time. As I was telling you, we have the choice here between two options: the easy way or the hard way, or the lazy way or the non-lazy way. So let's start with the easy way, meaning the lazy way. The lazy way is this. You're going to click here, browse more AMIs. Browse more AMIs. And here in the search, you're going to enter scikit. Yeah, you're just going to enter scikit. Okay, so quick start AMI 0, my AMI 0, AWS Marketplace AMI 39. Good, you're going to click on that. Okay, so why do I show you this? It's because in the code, as you can notice, well, we use a lot of libraries. We use pandas, we use scikit-learn, we use also NumPy, I think. Yeah, at some point, I think we use NumPy. And that's it. Yeah, scikit-learn, NumPy, and pandas. And when you use a server, when you launch an EC2 instance, well, you need to have those libraries and packages installed, on your EC2 instance, on your server. So the first option we have here is to take an existing AMI on which all these packages are installed. And actually, we have exactly what we need here: NumPy, pandas, and scikit-learn on Ubuntu. However, the drawback of this is that it's a paid EC2 instance. It's not part of the free tier. So we would have to pay for this. And that's why it's maybe not the best option. It's not that expensive. It's $0.10, 10 cents per hour. Okay. But yes, it's a paid EC2 instance. However, we wouldn't have to install NumPy, pandas, and scikit-learn. So that is the first option. And now, if I do cancel, the other option, which is the non-lazy way and the hard way, and that is free, of course, is to take our usual, Amazon Linux AMI, that is part of the free tier, with the T2.micro instance type, which same is free tier eligible. But here, the drawback is that we would have to install all the packages, NumPy, scikit-learn, and pandas. So tell me in the chat, which option do you want to go for? The easy way or the hard way? Do you want to go for that existing AMI, which is paid, and where we won't have to install NumPy, pandas, and scikit-learn because everything is already included? That's the purpose of the marketplace, to provide you with instances that have all the packages installed already. Or do you want to go for the hard way, where we will have to install everything ourselves? Yes, Federico, actually, it's quite easy to install the libraries, but we will still have to do it. Maybe we'll run into some errors. Maybe we'll have to do some debugging. That's what I meant. So it seems that you all choose the hard way. It seems that you choose the hard way, the free version, and the non-lazy way. Okay, so let's do this. Perfect, let's do this. Federico is right. It's not going to be that hard. We will just have to do it. We will just have to run those commands. Hard way for practice, Jeroen. Perfect. So you all agree with the same options. Great. We don't even have to vote. So that's perfect. Let's do this. So here then, because we all chose the hard way, well, let's make sure we choose Amazon Linux here. Then Amazon Linux 2023 AMI, which is free tier eligible. Okay, here you can keep the 64-bit architecture. And then in instance type, you're going to choose the T2.micro instance type, which will be way enough for us to do those 800 and I don't remember, 800 something computations and also 800 something trainings to get the R squared. Okay. Now, very important, because we're going to SSH into our EC2 instance, here we're going to need a key pair. Okay. So here you're going to click create a new key pair. Here you're going to give a name to your key pair and you're going to call it my key pair or whatever you want. So yeah, my key pair, then key pair type, you can keep RSA, then private key file format. So for those of you who are on Mac, Linux, or Windows 10 or higher, you can choose .pem. And for those of you who are on Windows 8 or lower, you can choose .ppk because you're going to SSH into your EC2 instance using PuTTY. Okay. So me, I'm on a Mac, so I'm going to use .pem. Let me know if any of you is using this one, .ppk. I also provided the tutorials teaching you how to SSH into your EC2 instance, whether you are on a Mac Linux, Windows 10 or higher, or Windows 8 or lower, to help you connect to that EC2 instance. Okay, so my key pair, rsa.pem, let's create this key pair. Great, perfect. Now we have our key pair. Then network settings, you can keep that. That's okay. Make sure you have allow SSH traffic from anywhere. You can even choose your IP, but it's okay. We're going to choose anywhere. And storage, this is fine. This is all good. Okay. So basically, we're going to create an EC2 instance from the classic Amazon Linux 2023 AMI, which is part of the free tier, with a T2.micro instance type, a new security group, which will allow SSH traffic, and a storage volume of 8 gigabytes. Okay, this is part of the free tier. Make sure you have that. And now let's click Launch Instance. Successfully initiated the launch of instance. Let's go to our instances. Okay, just making sure there is no question. So I suppose it's all good for you. You created your EC2 instance. All right, so this is mine here, my EC2 instance for machine learning. It is launching. It is still in the pending state. I'm just going to wait for it to be running. Yes, there it is, running. I'm also going to wait for the status check to be 2 out of 2 checks passed, and then we'll get started. No questions so far? All is good? Did anyone had to use PuTTY, the key pair for PuTTY?
I'm planning to use it, yes.
Yes? So you're on Windows 8 or lower, Jordan,
Yeah.
right?
Yes, yes.
Okay, cool.
But I have no problem with the key. It's okay. Until the machine
Okay,
starts, can I ask something? You mentioned the one hot encoding where you wanted 4 categorical variables, but you mentioned
yes.
you wanted 3 only. Can you quickly tell me why? What's about the 4th one? Because you have 4 values: north, east, southeast. So why are you happy with 3?
Okay, so let me explain to you why. So we have 4 values of the categorical variable for the region: northwest, northeast, southwest, and southeast. And we're going to encode these 4 values with only 1s and 0s, okay? But if you notice, we only need 3 columns to do that. Let me show you why. Because let's say that we're going to encode northwest like that, 1, 0, 0. Okay, that's northwest, west. Then northeast, we're going to encode it like that, 0, 1, 0. Northeast. Okay, and then 0, 0, 1 will be southwest. And finally, 0, 0, 0 will be southeast. So you see, with only 3 columns here, with those values,
I understand.
Well, we can encode 4 values of the column.
Yeah, okay, clear. Thank you so much. Clear.
Welcome.
You only need 3 placeholders to explain this to the code. I understand. Okay.
Exactly. Basically, when you have n values of a categorical variable, you need n-1 columns of 0s and 1s to encode it. Yeah, correct.
Thank you so much.
You're welcome. Okay, so everyone is good. Everyone knows how to SSH into an EC2 instance. I mean, I'm rather asking for the Windows 8 or lower users, because now I'm on a Mac, so I'm not going to be able to show it for Windows 8 or lower. But you have the tutorial in the prerequisites that I provided in case you forgot how to do it. But let me know if you have any question, of course, while I'm going to do it. Okay, so I'm going to refresh this. 2 out of 2 checks passed. Great, so we're ready. So now we have our EC2 instance for machine learning, the basic one from the free tier that is going to be free. Therefore, this lab is going to be completely free. Of course, make sure that you are still in the free tier, with an account that is less than 1 year old. So there you go. Let's do this now. Let's SSH into our EC2 instance. Okay. So do you remember how to do it? First, we're going to select it. Okay. We're going to select it and we're going to click connect. Then here, you probably have this first, EC2 Instance Connect. You're going to go to this tab, SSH Client. Okay. And then you're going to need this, which is the DNS of your EC2 instance, the public DNS of your EC2 instance, the address basically of your EC2 instance, which will allow us to SSH into our EC2 instance. You can even take this example command here, because this is actually what we'll need to SSH into our EC2 instance. Okay, so let's do this. Now what we're going to do is open a terminal. So for Mac users, you're going to press Command plus space and type terminal here, enter terminal. All right, there it is. I'm going to then launch this so that you can see it better. Let me know if it's okay for you. So that's the terminal on Mac. Press Command plus space and enter terminal. Then for Linux users, you're going to find the terminal here on the left among the icons. And then for Windows users, so for Windows 10 or higher, you can use the command prompt. And for Windows 8 or lower, well, you can use PuTTY, okay? So I trust you to check out the tutorials that I provided in the prerequisites in case you are not sure on how to SSH in your EC2 instance. I'm talking about Windows users, just because I can't show you here because I'm on a Mac, okay? So let's go back here. You can follow the instruction here. You open an SSH client, meaning a terminal, or the command prompt, or PuTTY. Then locate your private file. The key used to launch this instance is myKeyPair.pm. That's the name we gave to our key. So indeed, the first thing I'm going to do in the terminal is check where I am by doing pwd. Okay, I'm on my Hadlin root folder. Then I'm going to enter ls here to see the diverse folders. And remember where I put my keys? Well, actually, it's in the download folder, but I'm going to put it in my desktop folder. There you go, desktop folder. I'm putting my key in the desktop folder just so that it's also with my other resources, the live lab number 15 folder. And now, as you can see, when I did ls here, well, I have the desktop folder from my root folder. And so in order to access my desktop folder, I'm going to do cd here. That's in order to go to another folder. And then desktop, okay, like that. cd desktop, then I'm going to press enter, okay? And now, if I do pwd again, well, indeed, I am in my desktop. You see here, I'm no longer in my root folder Hadlin. I am in my desktop. And when I do ls to list the different folders and files of the folder I am in right now, well, I'm now going to see myKeyPair.pm. You see, the purpose now is just to find your key pair, myKeyPair.pm. Okay, good. So now we are in the right folder, the folder containing the key pair. We're going to run this command. Run this command if necessary to ensure your key is not publicly viewable. But yes, that's necessary actually. Otherwise, you will get an error. So let's copy this command, chmod 400 myKeyPair.pem. Let's go back to the terminal. Let's enter it here. Press enter. Okay, good. So now it makes sure that your key is not publicly viewable. And now finally, we're going to connect to our EC2 instance using its public DNS. So that's the public DNS, but that's not the command you should enter. What you should enter is exactly this one, all this, okay? So let me do it. I just copied the whole command in the example, not the DNS, the public DNS. I'm going to paste it here. And here, so this is not an example of any EC2 instance. This is indeed here the public DNS of your EC2 instance. All this is the public DNS of your EC2 instance. So in the example here, you should have the right public DNS. So you just have basically to copy this command, and this is all good. All right. So now we're going to test. Are you ready? 3, 2, 1, press enter. Okay, good. So here, just to accept, because it says the authenticity of your EC2 instance can't be established, but we know it's us, so it's all good. So we can enter yes here to continue to connect. And there we go. Welcome to your Amazon Linux 2023 EC2 instance, the EC2 instance coming from the Amazon Linux 2023 AMI with the T2.micro instance type. All right, so now we're connected to our EC2 instance. So congrats. Let me check if it's all good for you. Let me check if you were all able to connect to your EC2 instance, to SSH into your EC2 instance. All good for everyone? Yes, Jerome, perfect, perfect. Jerome, are you on a Mac also? Yes, okay, good. Okay, Mac, perfect. So this lab is gonna be very easy for you to follow. Federico, what about you? I suppose you are also connected to your EC2 instance. I don't know if you are on a Mac or a Linux or Windows. Nicolas, is it good also for you? Did you SSH to your EC2 instance? And what about you, Ray? All good for you, Nicolas? Okay. You're not running the commands. Okay, Federico. Okay, so yeah, if you want to redo the labs and run the commands, well, you will have the recording. No worries. Ray just following as well? Okay, no problem. No problem. And Jordan, is it all good for you? Because you are on Windows, huh? It's you who were on it's you who was on a Windows 8.
Actually, no, I was late, so I just came back late and I have to go. So I just watching the tutorial and
okay, no problem.
Yeah, no.
Okay, no problem. So if you want to redo the lab, feel free to watch the recording and practice.
Yeah, that's it. Yeah, that's it. Thank you.
Okay, perfect. And Federico, you have experience using SSH, so all good. You will be able to SSH into your EC2 instance whenever you want to do the lab. Okay, perfect. So let's continue. We're all on the same page. Okay, so now I just SSH into my EC2 instance. So now, according to you, what is the next step? The next step is to, of course, what is the next step? We want to run the code. We want to run the Python code in order to run all these 800 plus trainings, in order to get these 800 plus metrics of R squared, in order to find the best combination of hyperparameters among our 288 combinations of hyperparameters. So we need to run the code. But actually, right now in my EC2 instance, I have nothing. There is no data set. There is no code. We need to run the, in order to run the code, we need to access the location where the code is. That's how it works when we run Python codes from a server. But right now there's nothing. So according to you, what should we do? What is the next step? Exactly, Federico. Wow, I see you know your stuff. We exactly need to do this, SCP the files. So SCP means a secure copy. When you copy the files from your local machine to your server, okay? So that's one way to do it, indeed, to enter an SCP command in the terminal in order to copy the code and the dataset into the server. That's one way. But there is actually another way, which is more user-friendly. And do you know what it is? Nicolas, install packages will be for after. Yes, for now, let's just, make sure we put the dataset and the code into our EC2 instance, because now there's nothing. Jerome, S3, no, you have a good reflex, Jerome, but it's not S3. I'm thinking about a tool, a software to very, very easily move some files from your local machine to your server. Do you know what it is? Do you know this software? It's a pretty famous one, but it's really good. I want to show this to you. But of course, yeah, Federico is right. One way to do it is to use the SCP command to copy the files from your local machine to the server. Okay, so it seems that you don't know this software, so I'm going to tell it to you right now, and we're going to download it and install it. As always, I want to do everything from scratch with you, so I don't have it in my machine yet. I'm going to download it and install it and show you exactly the steps to be done. So that software is FileZilla. You're going to love it. You're going to see how so easy it is to, move some files from your local machine to the server, to your server. So let's do this. Let's enter FileZilla. Okay. Well, let's go here, the main link, FileZilla, the free FTP solution. So it's an FTP solution. Then you're going to click here, download FileZilla client. Okay. Here it recognizes that I'm on a Mac, so automatically I have the download link for FileZilla for Mac, FileZilla client for Mac. So yes, I'm going to download it. Then click here, download. You don't need to get FileZilla Pro. It will work very well with FileZilla. So download. All right. Just downloaded it. Here it's downloading. Okay, got it. Yes, here it is. I'm going to unzip it. And I'm going to put that in my applications. All right. So here it is. Now it's well installed on my Mac. Make sure to also install it on your Mac or Windows or Linux. And let's launch it. Click right, open. Yes, open. Error loading queue, this is fine. You can just press OK, you will get FileZilla. All right, now I have FileZilla. And you will see how so good, useful, user-friendly it is to transfer some files from your local machine to your server. Okay, so now the first step in FileZilla is to indeed connect to our EC2 instance. All right, we will see it well here. You will see it will be very visible. We will see all the folders and all the files in our EC2 instance, and we'll be able, from simple drag and drop, to move some files from our local machine to the server. You will see it's pretty awesome. So before we do this, the first thing we have to do is change the settings. So we're going to go, I think, into Edit. Yes, you will find the settings here in Edit. So next to File here, you go to Edit and click Settings. FileZilla would like to access files in your desktop folder, of course. Yes, because we're going to move the files from there to FileZilla, to the server. Okay, and then you're going to go here to SFTP. Of course, you can stop me if I'm going too fast. And then you're gonna click this, add key file, in order to do what? Of course, to add the key pair. Because in order to connect to your EC2 instance from FileZilla, you're gonna need your key pair, right? So that's the key, of course, to connect. So we're gonna click add key file here. Very good. Then we're gonna select this mykeypair.pem. We click open, and there you go. Now we have our key pair. Here it is. Okay, and then you press OK. Good. All good for everyone? Okay, we can close this. This was just to download FileZilla. Of course, feel free to stop me if I'm going too fast. You can unmute yourself and say, stop, please slow down or whatever. Okay, so now it seems to be good, so I'm going to continue. So back into FileZilla, after adding your key pair, now you're going to click this icon here, the icon of the 3 servers, to open actually the site manager. And now in my sites, you're going to click new site. You can keep the name new site, that's fine. So new site. Then here for protocol, you're going to enter, of course, SFTP, SSH file transfer protocol, because we SSH into our EC2 instance, SFTP. Then here for the host, according to you, what are we going to enter? New interaction time. Please, your turn to say what we are going to enter. Is it the public IPv4? Is it the private IPv4? Is it the host name? Is it the public DNS? What, according to you, are we going to enter? Host name, yes. So, Jeroen, how do I access the host name? Let's go to EC2 here. Let's go back to EC2. Is it here? I'm going to go back to my EC2 instance here, for example. I'm going to select the EC2 instance. And Jeroen, please tell me what exactly am I supposed to take? So, yes, it's, of course, the host that we have to enter, host, but what exactly the host in EC2? When I select my EC2 instance for machine learning, what is it exactly I have to take? This public IPv4 address, this private IPv4 address, or this public IPv4 DNS? Yes, exactly. Exactly, Jeroen, you're absolutely correct. What I have to take is this, EC2, then the public IPv4 address, then .compute1.amazonaws.com. Okay, that's exactly what is the host that I'm supposed to enter in FileZilla. Okay, so you take the host, you copy it from here, which is the public IPv4 DNS. You copy it here, and then back into FileZilla, you paste it here. Then for the port, you don't need to enter anything. That's fine. We are anyway using the SSH protocol, so it will recognize what port you take automatically. Then user, we can enter actually. Does anyone have any idea which username we should enter exactly?
Can you hear me?
Yes. So someone has an idea, yes?
Yeah, this is your own. Sorry, I have a bad microphone. I think you need EC2-user.
Correct.
Session
yes.
in the terminal.
Yes, so in user here, you enter EC2-user.
Also, instead of ask for password,
Jeroen,
I think you have to change that to the key pair.
Ask for password, change to the key pair, key file.
And then browse to the public-private key pair. Download it.
Okay, perfect. Excellent. Yeah, thank you so much, Jeroen. So in user, you enter EC2-user, and then key file, browse, and you select your key pair here. Let's try. Connect. Yes, perfect. Excellent. Thank you so much, Jeroen. Your help was very useful. And so now, as you can see, we have access to our EC2 instance. This is our folder EC2-user. And so if I do pwd here, there you go. Yes, this was the way to also get the user. EC2-user. I could have got it like that also in pwd. We are now in the EC2-user folder right here, all right, which contains so far the .ssh folder. Okay, and so now, as I was telling you, it's going to be super easy to put some files into our EC2 instance, because indeed, the only thing I have to do, I'm going to go back here, desktop. I'm going to put it like that. I'm going to do some simple drag and drops. Okay, so let's go to our Live Lab 15 folder. Let's select these two, and let's just do this. There you go. All right. So I simply dragged and dropped the dataset and the code from my machine to the server. You can even do a right click here, click create directory, and have this same directory, livelab15, but you can also directly drag and drop in the root folder, EC2 user folder. Okay, so great. Now in our EC2 instance, we have the dataset and the code, and therefore we can start running the code. But before we run the code, remember what we have to do. We have to install all the packages, because indeed we don't have them yet, right? If I try to run this code, for example, in the terminal, so let's just check that we have indeed the files. I'm doing an ls here to check the files, and there we go, we have them, insurance.csv, regressor.py. So now we have the dataset and the code inside our EC2 instance. Perfect. So I'm just gonna try first to run Python 3, and then let's try regressor.py. Yes, so as you can see now, I tried to run the regressor Python file, and as you can see, no module named pandas. So now is the time to install all these libraries. And indeed, Federico, I think it was you who said it was easy. As Federico said, it's very easy indeed. Let's first install pandas. To install pandas, we enter here pip install pandas. All right. It might even tell us to install pip. Let's see. Yeah, pip command not found.
The command,
let me try something else.
sudo yum install Python 3 works. I checked with ChatGPT.
Really? Which one? Which command?
That's what I put. Sudo yum install Python 3-pip.
This one. Okay, great. Thank you very much. I'm going to try this one. Sudo yum install Python 3 pip. Yes, perfect. Thank you so much, Nicolas. Okay, so now you enter Y. Yeah, we're all doing this lab together. That's awesome. Okay, great. So now we have pip for Python 3. That's perfect. So now let's enter again the one before, pip install pandas, and let's see if it works. Press enter. And yes, it seems to be working very well. Now pandas is downloading. That's perfect. Installing collected packages, the dependencies. Oh, it's also installing NumPy, so we won't have to install NumPy. That's good. We will directly install scikit-learn. Okay, perfect. Thank you so much, Nicolas. That was very helpful. So now we have pip. Now we have pandas, and we have NumPy also. It was automatically installed because it was one of the dependencies. Now, what is the only thing missing in order to run this code? It is, of course, scikit-learn. Okay. So again, because I'm like doing this lab with you from scratch, and of course I don't have the command in my head to pip install scikit-learn. I'm gonna do pip install sklearn. Yes. Let's see exactly what it is. Installing scikit-learn. Yes, you go to the scikit-learn website to check, and it's going to give us, yes, this one, pip install -u scikit-learn. Okay, let's take it. I'm going to enter it for you as well. Joan, you say it looks like Amazon Linux uses yum instead of apt as the package manager. You're absolutely right, Joan. Yeah, that's exactly that. It uses yum instead of apt. Good to know as well. Yeah. So that's the command to install scikit-learn. Well, actually, let me test it first, but it should work with no issue. Pip install -u scikit-learn. Yes, downloaded scikit-learn, downloading scipy. It's working very well. Perfect. Successfully installed scikit-learn. Great. So there we go. As Federico was saying, it was indeed very easy. That's the simple commands we have to enter in order to install pandas, scikit-learn, and therefore NumPy, which is one of the dependencies. So now, there we go. We can try to run the code. Let's see if it runs with absolutely no issue. So Python 3, and then the name of the code, which remember is regressor.py. Python 3 regressor.py. Ready? 3, 2, 1, go. All right. And yes, it's working very well. Congratulations, guys. And as I was telling you, it's testing now 860. Well, it's actually run 864 computations, 864 trainings of our random forest model, testing all these combinations of hyperparameters. So basically in the code, I left a parameter called verbose. I set it equal to 2 so that you can see what's happening, so that you can see what is being run exactly. So now it's testing all the combinations. You see some repeated lines, you see the same lines. That's because of the CV equals 3. Basically, it's going to do the trainings on 3 different pairs of training and test folds. So that's why you see, but for example, yes, now you see the difference. Here it was testing with 300 trees, and now it's testing with 1,000 trees. Now it's testing with 100 trees. Now it's testing with 200 trees. And then here for different values of the max depth, max features, minimum samples in the leaf, minimum samples per split, okay? So there you go. Now it's happening. Now the tuning is being done. Now 862 trainings are being run of our random forest model in order to test the different combinations of those hyperparameters. And for each training, well, it's of course computing on 3 different pairs of training and test falls, the R squared, and then taking the average of those 3 R squared to, get an average R squared. And then of course, what is it going to do at the end? It's going to give us the combination of hyperparameters, among all these hyperparameters that lead to the highest average of the R squared. That's exactly what is happening. That's exactly what tuning is. Well, tuning with grid search, it's computing all these training performance metrics, and then at the end, returning to us the combination of hyperparameter values that lead to that highest R squared. So at the end, you will see it's part of the code, but at the end, it will print not only the best R squared, but also that combination of hyperparameter values that led to that highest R squared. So it's going to take a little time because yes, it has 862 training to do, but as you can see, it's very fast, even though we took a very simple, basic EC2 instance. So yeah, it's running all these trainings. We will get the results in not too long, maybe 2 or 3 minutes. But yeah, it worked very well. Congratulations. And it was fun to do the lab all together. It's good like that when we all help each other to go over the steps and reach the finish line. Because honestly, it was the very first time I ran a machine learning code on such a basic EC2 instance. I usually took some existing ones from the marketplace with everything installed, but here it was fun to install everything from scratch. So yes, as you can see, it's testing all the combinations of hyperparameters. Here it's with 300 trees, minimum number of samples split of 8, minimum number of samples leaf of 5, maximum number of features of 2. And then, yeah, for each of those combinations, you have the training time actually, 0.5 seconds, 1.6 seconds, which is very fast actually. Remember that there are a lot of trees in the random forest. Random forest is not that fast to train, because of all the trees. So this EC2 instance is actually pretty good for us, even if we took the basic one. So yeah, we're probably halfway now. It seemed that it already did a couple hundred. So we should have the final result very soon. Let me check if you have any question. If it worked for you, yes, okay, no question. So it seems to be all right. So let's just watch the rest of the training and wait for the final results. And of course, we noticed that for the high number of trees, 1,000 trees here, well, the training time is higher, is longer, 1.7 seconds when you have 1,000 trees versus 0.2 seconds when you have 100 trees. Yeah, obviously. But it's still very fast. Can you imagine? It's training a random forest of 1,000 trees in 1.7 seconds. Pretty good.
Sorry, until it's doing this, can you show again the regression script and maybe we can visualize what the training is doing by you going in the code?
Yeah, basically the code right now that is being run is exactly this one, grid search, okay? As you can see, I chose CV equals 3, meaning that I chose to have for each combination that is being tested, 3 pairs of training and test falls, so that you have 3 trainings and then 3 evaluations on 3 test sets, okay? 3 trainings on 3 training sets and 3 evaluations on 3 test sets. And that is what's being run. And in each combination of hyperparameters that is being tested among all these values, and in each pair of training and test, well, in each training set, well, exactly this happens, okay? So we have our random forest regressor model, and we fit it, meaning we train it on the training set composed of X train and Y train. Then the rest are just other code for which the output is at the beginning, before the whole grid search. But there you go. That's mainly what is happening here. We have a random forest regressor model that is being trained on the training set in 3 training and test falls for each of those values of the hyperparameters. And then as you can see at the end, once it has tested all the combinations of our hyperparameters, well, it will print here the best R squared with 2 decimals. Okay, so we'll have, for example, 0.83. And then it will, of course, print the best parameters, that winning combination of hyperparameters that led to that best R squared. It's actually going to be a percentage. It's going to be a percentage. For example, I don't know, maybe 84% R squared. Okay. Then let me explain to you the parameter here. Estimator equals model. Okay, so that's our random forest model. Param grid, these are all the combinations of parameters that I put here in parameters. That's why I put param grid equals parameters. Then scoring, that's where I choose the performance metric to evaluate with, which is the R squared, of course. Then CV equals 3, meaning that we have 3 pairs of training and test folds when performing k-fold cross-validation, right? In order to have, 3 measures of the R squared on each of those 3 training and test folds, so that then we compute the average of those 3 R squared and we get an average R squared, which is therefore a more relevant measure of the R squared. And then edge jobs equals -1. This is in order to do parallel computing, in order to use all resources. And verbose equals 2 is in order to have this, what is happening, which combination is being tested. You see, thanks to verbose equals 2, we see exactly what is being tested, but it goes very fast because there is 0.5 to 1.7 seconds per training, depending on the number of trees, the number of estimators. But we see what is happening, which is pretty cool. And because it's going pretty fast, I think now we probably reached already 500 combinations, meaning 500 trainings. And so soon enough, in total, remember that we have 862 trainings to do in order to compute those R squared. So in a bit, we should have the final result. Clear for you? Is there anything else you want me to explain in the code?
It's clear, yes. Thank you so much. I need to...
You're welcome.
I need to brush a bit some values like R squared, but I'll do that later, so I don't hijack the session. Actually, I followed you, and mine is complete already.
Oh, it's complete for you?
Yeah, mine came up with the best R. I put a screenshot of the last lines in the chat. It came up
you
with
did?
an R squared
Wow.
of
So
84.
it's funny that it was faster for you. Okay, so mine should be ready soon, actually. Let's see.
Yeah. Yours should
let's
be
see what we
complete.
had. Yeah. Should be complete in no time now. Because you also took an Amazon Linux 2023 EC2 instance with a T2.micro instance type, right?
Yeah, actually, I think I took the one that they gave me default. But it's eligible in the free tier.
There you go. Okay.
Yeah.
Okay. So mine is ready also. It just finished.
84.46.
Yes, 84.46%. What did you get? Let me see yours.
84.53.
You got 84.53%. Oh, wow. You beat me. Congratulations. Okay. So you got the best R squared of 84.53%, which is very good. And remember that it's a relevant measure of the R squared thanks to k-fold cross-validation. And so your best parameters are, yes, bootstrap, yes. Maximum depth of 80, maximum features of 3, minimum samples leaf of 3, minimum sample split of 8, and number of trees of 200. Let's see for mine. Bootstrap equals true, max depth equals 90, max features equals 3, minimum samples leaf 4, minimum samples is 10, number of estimators 100. It's interesting that we got different results, but that's because of the randomness in the training and test folds, but still it's pretty surprising that we got different ones. Well, actually, your combination of hyperparameter is better because you got a better R squared. It's very close, but you got a better R squared. And sometimes a little better can make a big difference for some case studies, especially in medicine, for example. So congrats. You completed the lab to the end. Jerome, you too. Oh, Jerome got the best one, actually, 84.59%. Jerome, would you mind sharing your best combination of hyperparameters? Okay, Jerome got the best score. Okay, so you got bootstrap true, yes, max depth 80, max features 3, minimum samples leaf 3, minimum sample split 8, and estimators 100. Okay, so that's from all the combinations of hyperparameters we tested among the 3 of us. Well, Jerome got the best one, which is similar, by the way, to Nicolas' winning combination, right? Because you also have 3 max features, 3 minimum samples leaf, which is not what I had, right? I had 3 and 4 I had, okay. But you both got 3 and 3 for this. And yes, the number estimators is the big difference. I got 200, right? I got 100. Nicolas got 200. And Jerome, you also got 100. So yes, this is the main difference. Okay, very interesting. So Jerome, congratulations for getting the winner of the winning combinations. We got the three of us. Fantastic. Okay, so that brings us to the end of this lab. Of course, we're going to do the cleanup now. It's quite important that we did, even if we, choose the safe way with the free tier EC2 instance. But let's make sure we do it. Let's make sure we do it. So yes, let's do the cleanup now. We select my EC2 instance for machine learning. We click instance state, and then we click terminate instance. Terminate. And shutting down. Perfect. Bye-bye our EC2 instance for machine learning. Of course, you can keep it if you want to run some other code. It's completely your choice. Okay, now here, we don't have to do anything. Well, we could disconnect from here, but actually if you close this, it's fine. And then, as you can see, connection to EC2 Amazon.com closed, all right, by remote host. So you just have to close FileZilla. And here you automatically got back to your desktop. We're disconnected from the EC2 instance. So we can also close the terminal peacefully with no hassle. And there we go. Lab done, cleanup done, lab done. Congratulations. It was so much fun. Yes, Jerome, it was interesting to see the differences. Correct. But we all got close or squared. Huh? But as I was telling you, sometimes even a 2 decimal difference can make a big difference depending on the case study you're doing. So thank you so much for not only attending this live lab, but participating so well and helping me complete it up to the end. That was a great one. Now, do you have to delete the EC2 instance or is terminate enough? Yeah, terminate is enough. It will delete automatically after 24 hours. So basically in the EC2 console, let me show it to you again. In the EC2 console, now you see it terminated. This is fine. And in 24 hours, it will disappear. You won't even see it here. Even less than 24 hours, actually. Before it was 24 hours, but now it's 1 hour, actually, because the one you saw before, my EC2 instance, was the one I created to, prepare for the lab, but not with the basic EC2 instance, but with one of the machine learning EC2 instance from the marketplace. So I actually deleted that 2 hours ago. So I think now it will be gone in 1 hour. Yeah, you will see it gone in 1 hour. So no, you don't have anything to do. Yeah, terminated is fine. Ah, Nicolas, okay, you had a T3 micro. Okay, that's why you finished before. Yes, of course, a T3 micro is more powerful. It's faster computations. That's why, oh, interesting to see that as well, that you got faster training with a T3 micro. Yeah, very, very interesting. Cool. Okay, now I just have one favor asked, which is the same favor as any lab. That's just for the others, in order for them to know, how it is, if the lab is good. If you don't mind, please go to the live lab recordings here and provide your feedback or your comment on the lab. So you go to live lab recording space, then you go to this one, live lab recording 15. And then if you don't mind making a comment to say if you liked it or, giving some feedback, that will be very helpful for the future members of CloudWolf for them to decide if they want to take the lab. Okay? All right. Thank you so much again. This was a very fun lab. I will edit a bit the recording and provide it in that post very soon. We'll see at the top as usual. And until then, enjoy the cloud. Do you have any questions before we wrap up? Maybe you have some questions. Otherwise, we will wrap up. No? All good? Okay. Perfect. No question. Nicolas, thank you so much. Yeah, thank you. Thank you very much. See you in the next lab. Yes, absolutely. I'm going to stop sharing. Federico, thank you. Thank you so much for attending. Ray, thank you as well. And I'll see you in the next lab. Bye-bye, guys.